Hello friends, welcome back to another video. In today's video we are going to cover the topic of sets. Sets is the first chapter of mathematics of class 11th. So I will try to be regular for the YouTube videos. I will upload it regularly and my videos will be unedited mostly because it will help me to manage time, because editing takes so much of time. So let's start our today's video. So we are going to cover chapter number 1, mathematics class 11, sets. Now, what is a set? Set is a well-defined group of organized information. You have seen if you have gone toward the code, you have seen there are many types of a set. They have collected which have many different type of files and all that, which help in the hearing of the code. So that is called a set. Now the topic we are going to cover in our today's video, the part 1 of the explanation will be roster form, set builder, empty set, finite and infinite set, equal sets and subset. One more that I haven't written is power set. So these are the topic that we are going to discuss in today's video. So let's first of all talk about set. How we write a set. So for writing a set, we just have to put these brackets, okay, curved brackets at the both end, so that we can show that it is our set. So first topic, roster form. Okay, what is roster form? Let us talk about let us take a set. Our set will be, let's take a number 1 2 3 4. This is a set for us and we will name it A. Okay, this is a set for us for now. So the representation is known as roster form of the set. This representation is known as the roster form of the set, and every single different element, the thing that you can see, that 1 2 3 4 that is written inside those brackets are called element. Okay, are called element. So when we combine many elements together to form a set is called in a roster form. Okay, now second, this was roster form. Simply it was a very small topic. Second is set builder. Okay, now what is set builder? Set builder, as the name suggests, set and builder. Set, we have already known what is the set. Builder, it is showing or representing that it will help to make a set in the roster form. Okay, now let's take the same example that we were having a set A, which were named as A, and the element were 1 2 3 and 4. Okay, these were all the elements. Now what is set builder? That how can we write that what is happening in it? Okay, like if we say to make this set, we have to write in the words. Let's see, we can write it as x is x is natural number. X is a natural number which is greater than 0 but smaller than 5. Now this is our set builder. Okay, now let's study it. X, here every element, we are referring every element as x. So x is a natural number. What are natural number? The number that are from 0 to infinity are called natural number. Sorry, my bad. Not 0. They will considered as whole number. From 1 to infinity are known as natural numbers. We will write here 1. Bigger or equal to 1 and x is smaller than 5. Okay, now let's understand it. So we are taking every element in term of x. So x is a natural number, mean it is coming in between 1, it is 1 or in between 1 and till infinity. So natural number, and second that x is greater or equal to 1, is greater or equal to 1, which means either x can be 1 or it can be greater than 1. Okay, what is greater than 1? 2, 3, 4, 5 till infinity is greater than 1. And second condition that we have termed is that it should be smaller than 5, means it will in the set the 5 will not be included. 5 will not be included, but the 4 will be included because it is smaller than 5. And in the same set 1 will be included because we have stated that x is greater or equals to 1. Okay, so this was a set builder. Now let's take an example for it. Two examples we will take. First is that we will make roster form from the set builder, and second is from roster we will make a set builder. So we have let's take first example that we are given with that in the terms of x is whole number, x is whole number greater than 0 but smaller or equals to than 10. Okay, right? So in terms of x we will take every element in terms of x. So x is whole number, means it will come in between 0 or 0 till infinity, but the conditions are given that it should be greater than 0 and should be equal to or lesser than 10. So now we have to form in the, make it in roster form. This is set builder. Now let's convert it into roster. Now we are given with the condition that the set, first we will make the bracket, the set should be in, greater than 0, means which number is greater than 0? Obviously 1 is greater than 0. Okay, and we are given that we have to go till 10 because greater or equals to. Okay, this sign we all know that this is if we take 0x, this means that x is greater than 0. Or if we take this the same opposite, that then this will mean that 0 is greater than x. Or if we say that this which is greater or equals to x. Okay, greater or equals to x. So same is there also, that x will be smaller or equal to 10. So means we have to take 10 also, we have to include 10 in the set. So we will go to till 10, 2, 3, 4, 5, 6, 7, 8, 9 and 10. Because we have to include, because it is stated that smaller or equals to. Equals to is very important, so we have to state 10, we have to write 10 in the roster form also. So this will become our roster form, right? And now let's take another example from roster to set builder. Okay, sorry, not this bracket. We are given 1, 4, 9, 16, 25. Okay. So this is our roster form. Now we have to convert it into the set builder. Okay, we have to convert it in set builder. What kind of pattern you can see here? Just think what kind of pattern you can see here. The pattern we can see that 1 square is 1, 2 square is 4, 3 square is 9, 4 square is 16 and 5 square is 25. This pattern we can see here that 1, 4, 9, 16, 25 means this is the square of these numbers. So how can we form it in the set builder? So first see, let's take every element, let's consider every element as x. Now x, here you can see these are whole numbers or these are natural numbers. So we will write, it's your wish, you want to write whole number or natural number. I will go with natural numbers. So x is natural number, x is a natural number, and the condition and other condition that we will state, that we know that these are the square of consecutive numbers, right? So we will write x, okay, 1 plus, sorry, we will write, see, 1 square is 1, then 2 square is also is 4, then 3 square is 9. So we have to increase the x, but we have to keep the square same, we have to keep the power same. So we will write x plus 1 square, okay. And the condition that we will give, that 0 plus 1 is 1 and 1 square is yes, so x plus 1 raised to power, whole raised to power square. And the other condition that we will write is that x is greater than 0 and smaller than 6, okay. So this will become our set builder, because the x is greater than 0, 0 square is 0 and 0 is not included here, and 6 square is 36 and 36 is also not included here. So we will write that x is greater than 0 but smaller than 6, or as if you wish, you can write that x is greater or equal to 1 and smaller or equal to 5. It's your wish what you want to write. So this was some examples. Now let's know about the intervals in the set, okay. Let's know about the intervals. Now what is interval? As you have seen that I have stated here that x is greater than 0 and smaller than 6. So to represent, these both are called as interval. From where it starts to where it ends, both number is called intervals. Now if it is given that 0 is greater than 0 is smaller than x and x is smaller than 6, okay, so how we will write them? We will write them in the square bracket. Sorry, not square but normal brackets. X is small as x is greater than 0, so 0 is not including it in it, and smaller than 6, and so 6 is also not including. We will put them in normal brackets. You can see an example on the page number, leave it, I have to find it, that's very headache. But yeah, you have to put these in normal brackets, that the one you are not including in the interval in the set, okay, in the roster form. And think if instead of this 6 it will be 5 and equal to 5, smaller or equal to 5. So what we will do, that 5 is coming in our roster form, okay, 5 is coming. So instead of this small this normal bracket, we will put a square bracket, okay, we will put a square bracket. And but the side on the 0, we will put the same, and the bracket will remain the same, because 0 is still not including in it, okay. Did you got it? Now Now let's study about the empty sets. What are empty sets? Let's for example, let's think that we talk about that there were two students. Okay, let them be student A and student B. They were having two chocolates. Okay, let the chocolate name be Z and Y. The other student was having chocolate name P and Q. Okay, so they were having in total 4 chocolate, and both were having two chocolates named Z and Y and P and Q respectively. Now they first student, A student, gave its all chocolate or both chocolate to the B students. Okay, now the student A will not be left with any kind of chocolate. Instead, the B student will have both all 4 Y, Z, P and Q chocolates with him, right? So student A will not be having any kind of chocolate. Now what we will say, that is this set is what? We will say that this set is empty, and the empty set or empty space in the set is noted or denoted by phi. Okay, the sign of phi is making a 0 and a line between it is phi. Now this is called empty set, means it is not having any value or element inside, is known as empty set, and phi is present in every kind of set. Okay, now let's come to the another topic, which is finite and infinite sets. Now what is finite and infinite sets? It's simple as the name suggests. Finite sets are the set which have limited numbers. Like if we talk about 0 is smaller than x, but x is smaller than 6. This means the roster form will be 1, 2, 3, 4, 5, 6. Right? This will be the finite set. This will be considered in the finite set. But if we talk about infinite set, they may start from a point but will end at infinity, or they may start from infinity and at a point, or it may start from infinity and will end to infinity. How? Let's see. Like for example, if I say in a set builder, I state that x is multiple of 2. Okay, x is a multiple of 2 and is a natural number. Okay, and is a natural number. So see that we know 2 is the multiple of 2, but below 2 there is no number that is multiple of 2. So the roster form will start from 2 and 4, 6, 8, 10 till infinity, because infinite numbers are multiple of 2, right? Infinite numbers are multiple of 2. So this roster form will be known as infinite set. Now one more example, that think I say let's make a set builder that is saying that x is integer. X is integer and have a perfect root or square root. have a perfect square root. Now what will happen? See, integer, the negative numbers do not have a square root, right? They have a square but they do not have a square root. So again we will go with the natural numbers like or whole numbers like 0, 1, no sorry my bad, like 1, 4, 9, 16, 25 and so on till infinity, because infinite numbers will be having a perfect cube root, a perfect square root, right? Because the numbers are infinite and they will definitely infinite number will have definitely a perfect square root. So that's why we will go till infinity. So these were some example of definite and finite and infinite roots. Sorry, sets. Now next topic is equal sets. Okay. Now think of a situation the same situation that chocolate. Student A was having chocolate P and Q, and student B was also having the same chocolate P and Q. Okay, the students were also having the same chocolate. Now we can say that the student A and student B are having same chocolate, means the set they will form will be same. Or let us take a different example. We have said that there are two circles. Okay, there are two circles of radius 2 and 4. Okay, of radius 2 and 4, and we can say that there are other two circles in other set which radius are also same 2 and 4. So we can say that the A is equal to B, means the circle that was present in the set A is equal to the circle that is present in the set B. Or we can say that all the circles, like here the circle with the radius 2 in set A and circle with the radius 2 in set B are same. So the set also become the same, which means set A will become equal to set B. Okay, so this was topic of equal set. The next topic comes is subset. The last topic that we are going to discuss in this video is subset. Okay, now what is a subset? For example, let's take a set that and we'll name it obviously A. The set, let's take us the set 1, 2, 3, 4, 5 and 6. This is our set, right? Now what is subset? That another set we are having, we named it B. In that we have 2, 3 and 4. Okay, these two sets we are having. First is A, which is having element 1, 2, 3, 4, 5, 6, and second is B, which is having the element of 2, 3 and 4. Now you can see that 2, 3 and 4, all three elements are present in set A also with some other. So we can say that B is a part of A, right? We can say that B is a part of A, which means we can say that B